welcome to Business Calculus Increasing and Decreasing Functions. Here we have the graph of a function f of x equals 3x minus x cubed. And below that is the sign chart for f prime of x. We're interested in studying the intervals where the function f is increasing and decreasing. If we look at the sign chart, we see that the function f prime is negative. So from negative infinity to negative 1, we say that the function is decreasing, and we can see from the picture of the graph that the graph of the function is falling. In the interval from negative 1 to 1, we see that the function is rising or increasing, and in that region, the first derivative of the function is positive. And then on the interval from 1 to infinity, we see that the first derivative is negative again, and that the function is falling. There is a connection between a function that is increasing, which has a rising graph, or decreasing, which has a falling graph, and the slope of the tangent line. As we saw, positive slopes mean that a function is increasing, and negative slopes mean that a function is decreasing. Using our knowledge of continuity and sign charts, we can track where the derivative of a function is positive or negative, and thus on which intervals a function increases or decreases. Here's a little bit of an example. If we have an open interval, a to b, and the derivative of a function is positive, then we say that f is increasing. Over another interval, if we say that the function's derivative is negative, then f is decreasing. And so we see some examples of types of increasing functions, either straight lines, and the two types of curves that indicate a rising function, as well as a straight line and the two types of curves that indicate a falling function. To determine the sign chart for f prime, we have to find the partition numbers of f prime. Those are the values of x where the derivative is equal to 0 or the derivative does not exist. The set of partition numbers that are also members of the domain of our original function f are called the critical numbers of f, and usually represent important features of the graph of f. We will discuss the actual importance of these and define them in a little bit more detail in coming videos. Let's do some examples. Let's find the partition numbers of this graph, construct the sign chart for f prime, and then determine the intervals over which it is increasing and decreasing. So we start by calculating the derivative of the function f prime. And we see that we have 1 plus x cubed, so its derivative is very easy to calculate. It's just 3x squared. Now, the domain of this function is negative infinity to positive infinity because it's a polynomial, so there are no places where the derivative does not exist, but we do want to figure out where this function is equal to 0, and we see that the only value of x that makes 3x squared equal to 0 is x equals 0 itself. So that tells us that when we construct the sign chart for f prime, our only partition number is 0. And it's in the domain, so we're going to represent it with a solid dot. We'll put 0 here. And then what we need to do is test values in this region from negative infinity to 0, and another value between 0 and infinity. So if I choose, say, negative 1 and 1, if I plug negative 1 into my function, we see that we get 3 times 1, which is 3, which is greater than 0. So the function f prime is positive in this region. And if I plug in 1, we also see that my answer is 3. So the function is positive in this region. And we see that in accordance with the pictured graph here, that the function is rising for all values of x. So we say that this function is increasing for all real numbers. Okay, let's do another example. Here, we would like to find the derivative of the function f of x equals 1 minus x to the 1/3 power. So we start by calculating the derivative, and this will require the general power rule. So we get 1/3 times the inside left alone. We subtract 1 from the exponent, and then we multiply by the derivative of the inside, which is -1. Next up, we want to try to simplify this a little bit. So we get -1 in the numerator divided by 3 times 1 minus x to the 2/3 power. Okay? And we want to know what the partition numbers are for this. F prime of x does not exist. When x equals +1, because that makes the denominator equal to 0, so that represents our only partition number. So we draw our sign chart for f prime, and we see that 1 is going to be the only value that we graph on here, and then we want to pick some values to construct our sign chart. So we will plug in 0, because we get to pick 0, a value from the interval from -infinity to 1. I get -1 divided by 3 times 1 minus 0 to the 2/3 power, which is going to be equal to -1/3, which is negative. So we see that the function is decreasing in this interval. Next up, we plug in a value on the other side. We're going to pick 2, because it is a value on the interval from +1 to infinity. So we're going to get -1 divided by 3 times 1 minus 2 to the 2/3 power. That's going to be -1 divided by 3 times, we have -1, because it's 1 minus 2. We're squaring that, so it's going to be a positive number, and then we're taking the third root. So ultimately, the value is 1. But the most important thing is that we recognize that whatever is going to end up in these set of parentheses here is positive, because the only thing that we care about is whether or not the function is positive or negative. We see again that the result is -1/3, which is less than 0, so we say that the function's derivative is negative in this region as well, and this tells us that the function is decreasing for all real numbers. Again, because it's decreasing, the function's continuous at this point, and then it's decreasing from 1 to infinity as well, since it's decreasing everywhere technically, even though the derivative is not defined when x equals 1. We say that the function is decreasing for all real numbers. Alright, we have one more example. We would like to analyze the intervals where the function f of x equals 1 over x plus 2 is increasing or decreasing. Again, we start off by calculating a derivative, and this is most easily done by thinking of this as the function x plus 2 to the -1 power. So we're going to get -1 times x plus 2 to the -2 power, and then we're going to multiply by the derivative of the inside, which is just 1, because it's the function x plus 2. We can simplify this, and we get -1 divided by x plus 2 quantity squared. goal is to determine where the derivative is equal to 0 or where the derivative does not exist. There is no value of x that causes the function to be equal to 0. So we have none of these points, but we do have the situation when x equals -2 that the derivative is not defined because it makes the denominator 0. So this is going to represent our partition value. I'm going to represent this with an open circle because we have the derivative not being defined at that point. This breaks up the real number line from the interval from -∞ to -2 and from -2 to infinity. Now we pick test points from each one of our regions. We'll pick -3 for the left-hand region and plug that value into our function. We get -3 plus 2 squared, which is going to give us -1 divided by 1, which is a negative value. And as we see from the graph, the function is decreasing in that region. To complete our sign chart, we select a value from the region -2 to infinity. We're going to pick 0. So we get 0 plus 2 quantity squared, which is equal to -1/4, which is again a negative value, so we see that the function is decreasing in the region from -2 to positive infinity. Now, overall, when we talk about the intervals over which the function is decreasing, we do have to skip -2 because -2 is not in the domain of the original function. So we say that the function is decreasing from -infinity to -2, union -2 to infinity. Now, my use of parentheses here shows me that -2 is not included. If I wanted to include -2 in the interval, I would have used a bracket instead. So keep that in mind. Remember how interval notation works. Alright, what I would like for you to do to finish up is to find the critical points of the function f of x equals 1 divided by x plus 4. Here are some potential responses. And thank you very much for listening. I'll see you next time.